All right. Well,
All right.
welcome everybody. It's Saturday night, and we're coming to you. Actually, half of us, or one of us, is coming to you from the Chabot Space and Science Center in Oakland, California, and the other two are at home. Tonight, unfortunately, we have very bad weather at Chabot, and so we are not able to open our telescope. We are completely socked in with fog and wind, and the fog is right down on the deck. So we are not able to open our telescopes tonight. So we're going to have to do virtual tonight. Want to remind everybody, Chabot Space and Science Center is closed to the public right now. We do plan to reopen later on in the fall. But in the meantime, because we are continuing to do our virtual programming and also we're refreshing all our exhibits and doing some other preparations for our reopening, we do need to continue receiving support since we don't have people coming to the gate. We don't have our normal ticket sales. So we do rely on donations right now. So if you're on Facebook, you'll see a donate button. Go ahead and click that and make a donation. We would really appreciate it. You can also go to the Chabot Space and Science Center website. The URL is chabotspace.org. And if you go there, you'll see a donate button at the top of the page. And just, help us out with a little donation. Also, if you are working for a company that likes to support nonprofit organizations, you might want to mention Chabot Space and Science Center to them. We always look for corporate sponsorships. You may have noticed at the beginning here, Fremont Bank is one of our sponsors, and we really appreciate it. So we'd like to invite other corporations to join them. So it looks like Rich has solved his YouTube problem. So I think we're ready to go.
I fixed YouTube
Yep.
single-handedly.
Yeah,
Yep.
yeah,
It is
yeah,
working. You can see
Yeah, I,
that.
I actually
yeah.
didn't do anything. I switched over to YouTube, and all of a sudden it was working, and people there say that they could see, and so I'm happy. Gerald, you disappeared.
Uh
Oh, only
There he
momentarily.
is.
oh.
Yeah, yeah. I had to
All
do
right, so
something
yeah,
that
we
I
have.
didn't want the world to be watching. So
Okay.
Oh. So
Enough
as
said.
Gerald said, it's a virtual program tonight, and but this was an exciting week, and well, for the part of the week I remember, because following all the excitement, I have 2 days of complete blank memory of what I
what
did
day
and
is
where I
this?
did. But what day is this exactly?
Yeah.
So on Tuesday night, Wednesday morning. The three of us and Rick Taft were up all night. We could still do it, and
Barely.
we were doing a live program of the total lunar eclipse, and I'll tell you, it was a very beautiful eclipse. It was stunning, and I've seen several of them. And this one had a certain color and contrast to it that I really don't remember from the other most recent ones.
And
I don't know if it's just me or not.
even though it was
Yeah,
an all nighter, it was a fun night. We had a lot of fun.
it
Yeah.
was fun. So I've
I,
been busy curating some photographs, and so when we get to that, I've got some photos to show you. It's always fun to wait a few days after an event like that before you show photographs, because everybody's had a chance to sort through their dozens or hundreds or thousands of images, and
Pick out the
modify the
best, right?
contrast, pick out the best ones, stack them, superimpose them on other things, and comment on how they acquired it. It was just the right amount of time between then and now to get some of that. So that's one of the things we have on our plate tonight. And I don't know, unless you guys got anything else, we could start with that.
yeah.
It's up to you.
Let's see some photos.
Okay, let me
Well,
go ahead and
while
get
you're
that
getting set up, one of
ready.
the interesting things about our coverage of the lunar eclipse was that we had a very much an international audience. over the course of the 4 hours. I can't believe we found something to talk about for 4 hours. But anyway, over the course of the 4 hours, we had some 93,000 hits on our YouTube and Facebook websites. And they came from all over the world. 111 countries were represented in all those comments that we received over the course of the 4 hours of that eclipse. So that was pretty amazing.
Well, let's be honest here. We didn't have to find something to talk about for 4 hours without repeating ourselves. We repeated ourselves
A
several
few
times.
times.
So that was that's one of the beauties of doing these long programs about astronomy is that you have to repeat yourself over and over again, and you don't run out of material because people are coming and going all night long. That's the interesting thing about some of these viewing numbers as well, is people are channel surfing, right?
Yep.
They drop in for a while, they stay for 10 minutes, they stay for an hour, they stay for 30 seconds, and then they move on to something else. But what was fun was watching people announce what countries they were in, and that was kind of a blast.
Yeah.
So
well, let's stop talking about it. And let's see those
all right,
pictures.
let's see some pictures. Okay, here we go. Let me get this up and running. There we go. Do you guys see that first one?
Yeah.
Okay, so this was our setup on Tuesday night, Wednesday morning, and
from your point of view,
from my point of view. But Rick took this picture. Rick Taft took this, and this was right after sunset, and you could see Nellie in the background, and you could see the lights on in the observatory. And I was running the back end Zoom and Facebook and YouTube links from out on the deck, and had a C8 Celestron 8-inch telescope set up next to me. So that way I could be also photographing the moon while the main telescope was being used for the program most of the night. And also we knew. Go ahead.
That's your workstation in the foreground there, where next to your C8 telescope, and then there's another workstation inside the observatory next to the 36-inch telescope.
Also, if you look closely at the 36-inch telescope, you'll see that the front cover is on it.
Right.
We didn't really use the telescope. We used its finder scope.
And on that note, that's what it looked like. So you could see that the finder scope was the instrument that was used most of the night. It had the right field of view and the right focal length, and Rick's camera is attached to the back of the focuser. There's no camera lens. The telescope is the camera lens, right? And you can see the preview screen to the left of it has got the entire moon, or at least the entire area of the eclipse within the field of view. And this is a particularly nice camera. This is a Canon DA camera, which is, or DA, or is it RA?
RA.
That's right, RA camera. Thank you. It's a Canon RA, which is an astronomical camera, which means that the infrared filter was removed. It makes it very sensitive to red in particular. And since the eclipse is a red event, you got a blood moon, you get a lot of vivid color out of it long before I'm able to pick out that color on an unmodified camera. So it was really great that Rick was there with this camera, and it really enhanced the evening. His image, or his images, looked a lot like this, and you can see how the red is really stands out. And this was probably right at totality. I'm thinking it's either right before, or right at totality. And you'll notice that what was interesting about this eclipse, and you guys can comment on this because this is what I don't remember about other eclipses, is the extent to which the top of the moon was bright and white. Usually we get really the entire moon is blood red, and we don't have this same degree of contrast. And I think this was because it was skirting the edge of the umbra.
That's correct. Yeah,
Yeah.
it was just inside the umbra, right at the very top edge of the umbra. So, the upper part of the moon it's probably in the umbra, but just barely in the umbra. And so, because of the exposure that he had, it's actually slightly overexposed at that part of the image.
Also, based on where the bright spot at the top is, I'm guessing this is right after the totality, and instead of right before it. I think that's right afterward.
I think it could have been either way, right?
Yeah, I think it's right about.
Yeah,
right
but afterwards it was more to the 11 o'clock position, and
Well,
before it was more to the 1 o'clock position.
I have the answer for you.
Okay.
If you look at the lower right corner of the photograph, it tells you the time. So it's 4:20, which was right in the last 5 minutes of the eclipse.
Right.
Okay.
So this
Right,
is actually during totality, because I think it ended at 4:25. Is that correct, Gerald? I think I seem to remember
423.
4:25.
Yeah,
Or
yeah,
4:23.
425. Yeah, 425. You're right.
All right. So so this was well within totality, yet you still had that bright
But
area
at the very
up on
end
top.
of totality, not
But
the
at the
beginning.
last 5 minutes of it.
Right.
That's correct. Anyway, beautiful image, Rick. This one is from Jared Wilson, and Jared is a longtime EAS member and really one of the best astrophotographers that has come through EAS. He's got a very professional setup and is very meticulous. And he took this lovely image of the moon during eclipse. Did he mention that he had stacked some of
Yes.
them in order to bring out more background stars?
He said that this is actually a stack of 5 images. Each image was 0.4 seconds long. And then he stacked them, to get a little better contrast and get rid of any noise. The white dots you see, those are background stars. He was able to capture them. So this is a really great image.
It is. And now you can see the stars that you mentioned you weren't able to see, Gerald.
Yes.
Yeah, they're all here.
And hey, Mark is asking what the specs are on the finder scope for Nellie. It's a 5-inch refractor.
F12.
F12. Okay.
Yeah.
Is it from TMB Optical? Is that who made
DNG?
Oh, it's DNG. Okay.
Yeah. Actually 2 of them on our 36-inch telescope.
That's right.
On the north side and one on the south side.
All right, this was my take on it, and this was not taken through the finder scope on Nellie. This was taken through the C8 telescope that I showed you earlier, and I poured through a lot of photographs, and turns out that the one at 4:24 p.m. right before the end of totality was the one that I liked the most, and I liked it because of the contrast between the 4 o'clock and 11 o'clock positions. I like the really bright upper left and the really dark lower right. And this is completely unprocessed. This is just raw out of the camera. In fact, the camera did the JPEG conversion, and I just kept it as is without any changes. So it really reminded me of what it looked like to my eye. And so I went with it. And I was real happy with the focus because sometimes I forget to focus properly. All right, next. This is what happens when you hit the tripod. But this is from Dan Smiley. He posted this on the TAC, the Astronomy Connection list today, as kind of a funny photo of the eclipse. And I thought it was hilarious. He says, this is what happens when you kick the tripod by accident when you're walking by to make an adjustment. And there you go. I hadn't seen any other eclipse photos like this. So it's a funny one.
It looks like there's a companion moon sucking
Right.
material from the real moon.
Or the moon worm.
Yeah, right.
All right, the next one. This is from Rogelio Bernal Andreo. And this was not artificial in the sense that he didn't go like find some photograph that he had taken a year ago and combined it with the eclipse. He actually took it with some leaves. And Rogelio is one of the world's best deep sky astrophotographers. He's renowned for his Milky Way images and for a lot of his deep sky work, and he has books on PixInsight. He's spoken to EAS and various other organizations before, and so this is really outside of his usual thing. So he almost did it just for, he did it just for fun. So we all thought it was nice, and it's kind of fun to put a foreground in, and that's Rogelio's shot. This is from Molly Wakeling, and Molly is an EAS member, an astrophysics student. She's actually going to be moving back to the Midwest pretty soon if she hasn't already. I guess she hasn't already because she has the eclipse at the same timing that we did. And she did a composite of the entire eclipse that was visible from the West Coast, which is uneclipsed in the lower left to totality on the upper right, and I thought this was quite nice. Did a good job.
Yeah, that's a really nice image, and it's a typical image when you're doing eclipses. These aren't all stretched out like that. They take all of the images of the eclipse and then they line them up in a pattern like this so that you can see start to finish.
This one's interesting because usually you see them where whatever the totality event is in the middle, and then you see it coming out of totality at the end. But we didn't have that opportunity. I mean, we really basically the moon set right after totality, and so you had no choice but to do it this way. And it's more in a lot of ways it's more interesting this way because usually you see this fully symmetrical thing, and this is kind of neat. So anyway, good job, Molly. I don't know if you're listening or not, but there we go. Now this is the most interesting one that I thought that I've seen, and this is from Tara Mustafi. She is a Mount Diablo Astronomical Society member, and she wanted to do something really hard, and she managed to pull it off. And what this is a composite of the lunar eclipse and also the region behind the eclipse, which is the Rho Ophiuchus region, and Ophiuchus being one of the constellations that the moon passes through on its path across the sky. And what she did was take longer subframes with her camera to get out the detail of the dust and deep sky objects, and short frames like fraction of a second or just a few seconds of the lunar eclipse, and then overlaid the eclipse with a deep sky image of the background that the eclipse was happening in. And she submitted this to the Astrophotography of the Day committee, and I hope to see it on the NASA site sometime soon if she gets it. If not, though, it's even so, it's a really well-deserved effort. A little more detail, though, on on the processing. The processing she didn't do. It was a friend of hers in Moldova who apparently does a very good job with astro processing, and the number of frames for the lunar eclipse there are 9 frames of 3 seconds for the moon, and 30 second exposures, and it doesn't give me, she doesn't give the count on the 30-second exposures, but quite a few 30-second exposures for the background stars. And this one didn't even involve a telescope. It was a camera and a zoom lens, and on a camera mount, a camera star tracking mount. So
Right.
Hey,
Yeah.
Richard,
yeah,
what did you say was the constellation?
it's
Ophiuchus?
Rho Ophiuchus complex.
You sure about that?
Because
Well,
the
that's
moon
what
was
it
in
says. Yeah,
Scorpius.
well,
Yeah, because
it's a
I
wide.
see
It's
Antares to the left and M4 below it.
Are you
yeah.
sure that's Antares? I'm not sure.
I don't think. I think that's Rho, and that's
M4, isn't it?
no, that's not M4. That's not the right pattern for M4.
Well, I could be wrong. I was wrong once before.
Yeah, I'll go ahead and try to find. After I finish this
Yeah,
and turn it over to you guys, I'll find the
actually,
star map
I'm looking
position.
at a pattern of stars on Starry Night right now that matches up with those. So
Okay,
I think you're right. I think that's
it's a wide field background.
Ophiuchus.
Yeah,
Ophiuchi.
yeah. Okay.
Yeah.
Well, that's
Oh,
good.
well, whatever.
Otherwise, I'd have an embarrassing conversation with her in a month. Anyway, good job, Tara. This is pretty. And I think that's what I've curated for the day here. So I'm gonna stop sharing. Let's see. Got any comments here? Yeah, no, David, that's not M4. And it's not Antares. And it's not M4. And it's not Antares. And Tim liked the image. All right. No questions though.
That's
Let's see
interesting
what's
because when I'm
on.
There's nothing on YouTube either, except for
right.
comments.
All right. What else we got, guys? You guys have any? You had something, Gerald,
yeah, well, tonight,
from
if
Jared.
if we were observing tonight here at Chabot Space and Science Center, we would have looked at probably a few galaxies and some globular star clusters. And there's one particular globular star cluster that's very popular with astrophotographers. And Jared, the guy who took one of those lunar images, he submitted a image of the globular star cluster M13. Let me see if I can get that up here. Hang on just a second. Share screen. There we go. So this is a globular star cluster called M13. It's in the constellation Hercules. And this was a very long exposure. I believe he said he did an hour at each color. He shot through red filters and then blue filter, then a green filter, and then combined them all. A whole bunch of 1 minute exposures, totaling up, I think, 3 hours altogether. Um, and he did this from his backyard in downtown Oakland. So he had to do a lot of processing to get the sky glow out of the image, and he got most of it out of there. But this is M13. M13 is about 25,000 light years away from us. It's a globular star cluster, which means that the stars in the cluster are orbiting around the center of the cluster, and the cluster orbits around our galaxy out in what's called the halo of the galaxy, which is outside of the spiral arms. One of the cool things about this picture is if you look off here, you see a background galaxy that he was able to capture as well.
When you showed us that image earlier, I had no idea it was taken from downtown Oakland. That's amazing.
Yeah, he
He
Yeah.
really did a great job
That's
there.
right.
by Lake Merritt. So,
Wow.
yeah. So he had to do a lot of processing to get it to look this good. So,
Yeah.
so anyway, I thought I'd just share that since we're not going to be able to see M13 with a telescope tonight. We might as well take a look at a really nice image that Jared Wilson sent us And, one of the things that's cool, if you look carefully, you'll see a few blue stars within the cluster. And those blue stars we call blue stragglers. Globular star clusters are very old. They're more than 10 billion years old. So there should not be any high mass stars left. High mass stars have very short lifespans, and high mass stars are the ones that are really hot and often have a bluish color to them. So since it's so old, there shouldn't be any more high mass stars. They should all have died off by now. And yet we see these blue stars within the cluster, which at first blush you would think means there's still high mass stars there. But it turns out those are stars that suffered some sort of a collision with other stars. So they are, in fact, old stars, but a collision either stripped off the outer layers of gas of a star or caused two stars to merge. And that's how you suddenly had a star which is now once again hot enough to produce that bluish color. So the term astronomers use for those blue stars is blue stragglers. They're they're not original high mass stars. They're stars that were low mass stars, but somehow or other they've been modified to shine in that bright, very hot bluish color. So anyway, that's kind of cool. This is he's using a special kind of telescope. It's called an astrograph, which is optimized for astrophotography, and he's got a very high-end setup that he uses with a very precise tracking mount, and by taking lots of individual short exposures, 1 minute exposures, and then combining them and processing, he gets this really spectacular image. Anyway, something to share.
Good. I have a more, since we were sitting here continuing this debate on the Rho Ophiuchus thing.
Yeah,
I want to give you my theory, and you can shoot it down all you'd like, and so can Dave Shaw and Alan Roche, who are on online. So here is the sky. You guys can see that?
Yes.
And when I say the sky, I mean the software product.
Yeah, that's what I
Not the
thought you meant.
actual sky.
Yeah.
All right. And this is as of 2 a.m. on Wednesday
26th.
morning.
Wednesday morning.
On the 26th.
Yeah.
I should probably bump it up to 4 a.m., but I figured, what the heck, it's not going to be that different. And here's the moon, and here's the Rho Ophiuchus region. And I believe that next to the moon, we were seeing M80, which is not the big cluster that we were talking about,
okay.
but a smaller one.
Yeah.
And my theory is that the larger one that we were seeing, that was very symmetrical, and because M4 does not seem symmetrical to me when I look at it. I look at M4 a lot, and I didn't think that was M4, but I think it's NGC 6144. Which is also a fairly bright globular cluster. It's a magnitude 7 globular cluster. And this is the star that we were seeing. And in fact, you can even see that it's a double on the original photograph. And that's got an IC nebula and a bright star. So I'm going to switch back to the photo now, because I'm sure everybody forgot what we were looking at before. And here it is. And so there's the moon. And I think this is M80. And I think this is NGC 6144. And I think this is Hipparcos 8804, along with that reflection nebula IC 4605 next to it.
Okay.
That's my theory.
All right.
And M4, if M4 was visible, it would be down below this glowing region here.
Okay. Okay, I'll take your word for it.
It's just a theory. Don't take my word for it. I'll ask her when I talk to her.
All right. Okay, well, what else do we have? Anything going on in the wonderful world of space?
Stefan
Well,
asks,
go
or
ahead.
Stephen asks,
Yeah.
how did he track? I assume he means she. How did he track and align the photographs? We don't know, I guess.
Well,
Are
yeah,
you
you
talking?
can
The
What are you
use
talking about? Jared's? Yeah.
use software to do that. There's
yeah,
software that will identify the stars within the image, and then you tell it to stack, and it will stack based on those stars. There's a couple different ways of doing
line all the stars up.
Right, right. So you identify a couple of stars that it uses as kind of registration marks, if you will, and then the software will automatically line them all up so that they all stack and look good.
And the ones that do it automatically, what they do is they will take an image and a reference image. You pick one that's nice and sharp that you like, and it will draw. Let's say you wanted to align on triangles. You could pick what kind of shape. In PixInsight, you pick which geometric shape you want to align on, and it will draw in memory every possible triangle it could find among the stars in that image. And then it will do the same thing on all the other images and try to find the similar triangles from one image to the next and do the alignment that way. And then others, you actually have to pick the stars and then align them manually, like Gerald said.
Yeah, yeah. I have one program where you tell the software where the telescope is pointing in the sky, and then it goes out and it queries a huge database, the Gaia Release 2 database, and it will identify all the stars in your image from the catalog, the star catalog. And once it identifies the first set of images, then it can go and do the rest very quickly. And it's literally identifying all the stars or all the major stars in the image, and then it lines up all the images for you. It's pretty handy, and it does it really fast. There's different ways of doing it.
There was a question about the clusters. How
Yeah.
close are the stars to each other on average towards the center of a globular cluster? It would be interesting to think about what would happen if one of the central stars in the core went supernova.
They are very close together, much closer together than the stars around our sun. Just to put it in perspective, that globular star cluster is a little over 100 light years across, and it has 500,000 stars in it. So just to kind of relate that, the closest star to our sun is about 4 light years away. So if you had 100 light years and you space stars at every 4 light years, you'd only have 25 stars in that 100 light year width. Here you've got thousands of stars, so they're very close together, much less than a light year near the core, and they're moving very dynamically. So they're moving relative to each other. And again, I was talking about how sometimes they collide with each other, and that's why they're so close together, especially at the core. One of the things that we often tell people when we're observing is that if you lived on a planet orbiting around one of those stars in that cluster, you would not have a nighttime, because you would have so many stars so close to you in your night sky, it would light up your night sky, and it would be like having 100 full moons in your night sky.
Well, that doesn't sound so great.
No,
no.
well, there's a book. I believe it was written.
Yeah.
I believe it was written by Isaac Asimov.
Yeah.
Somebody may correct me. It's called Nightfall, and it's a science fiction book about a civilization living on a planet orbiting a star in a globular star cluster. And because of the orientation of the stars, once every 100 years, they have a true nighttime. All the rest of the time, they don't have a true nighttime. But once every 100 years, they have a true dark sky night. And so it's a story about the experience of, I guess, a young boy
Yep, I
going through
remember
that.
that. It's a novel. It is a small. It's a short novel.
Yeah.
It's longer than a short story, so it's called a novelette, and it is by Isaac Asimov, and it was written in what year do you think it was written?
Like the 1940s, wasn't it?
Yeah, 1941.
Yeah, yeah.
Yeah, his writing is timeless. Is
Yeah.
really gay. Yeah, I guess yeah, it's certainly not a short story. It's 352 pages.
Oh, that's
So that's
a
actually
novel.
that's novel length. That's a novel.
Yeah.
All right.
Stephen
Stephen
asks.
asked,
Oh,
is
okay.
there? Yeah, go for it.
No,
No,
go
no,
ahead.
go for it.
Well,
It's your
I have the
job.
answer, so go ahead. So, yeah, he asks if there's
Okay.
a solar eclipse coming up soon, and Bob answered that there is one on June 10th, but I'm not sure where that is. The next one visible from anywhere near here is April 8th, 2024. That'll be a big, another great American solar eclipse that passes through the entire country.
Yeah, the one next month should be visible from, if I remember correctly, it's western British Columbia, going down or across southern Canada. Is that right? And
sure.
so we might get partial here in the U.S. and it's an annular eclipse. It is not a total eclipse.
Yeah.
An annular eclipse is when the moon's apparent size in the sky is smaller than the sun's apparent size. So what you end up with is what's called a ring of fire eclipse. Mm-hmm. So the sun is not entirely obscured by the moon, but is mostly obscured by the moon. And depending on where you are observing from, you might actually see the moon pass through the center of the apparent view of the sun and leaving behind a ring. It's kind of cool. Yeah. Annular eclipses are neat.
So there's a question on YouTube. Why is it that the moon turns red during a lunar eclipse? And I've got the answer right here.
We answered that the other day a few times, I think.
Yeah. I think we showed
that. That's what I was talking about. We're still doing it.
Yeah. So not to repeat ourselves, but so here's the Earth. Sunlight's hitting the Earth on one side. The moon is on the exact opposite side of the Earth. The sunlight, as it filters through the Earth's atmosphere all around the perimeter of the Earth, the sunlight is filtering through the atmosphere. The atmosphere refracts the light. It sort of bends the light and it bends the colors differently. So the blue and the green are actually refracted away from the shadow, but the red part of the spectrum is refracted into the shadow. And so that sort of fills the shadow, the main part of the shadow, with that red light. And that's what makes it look red. So there's your answer.
Yep. I'm seeing if I can find a map of the solar eclipse that we were talking about, and oh yeah, here it is. Let me see. It's way north. It's way north. So it's not really southern Canada. It's more. Oh, that's an interesting eclipse. These Arctic ones are very strange looking. Here, I'll show you the.
Bob said it's in the Arctic center.
Yeah. There's the map of the eclipse with the full annular eclipse being visible if you're in this red zone, and you can see that it does start off in southern Canada. It does not. I was wrong about British Columbia. It's actually more like the
Ontario.
Ontario
Ontario
area.
yeah.
Yeah,
Toronto.
and going up through Newfoundland and Newfoundland and Western Greenland, and also visible from northern part of Russia. And
Siberia looks like.
yeah, and none of the places that I'm going to be. That's for sure. So anyway, that's where it's visible from, and it ain't us.
All right.
Speaking of the moon, I did have something. So I read something interesting today, and there's been a whole series of planned missions to the moon over the next several decades. And we've seen that China has launched a rover, and that was successful and landed on the far side of the moon. The European Space Agency is planning several missions to the moon. There are missions to the moon orbiters that are going to be continuing the search for water. The United States has been talking about additional manned missions to the moon. So there's a lot of talk about sending missions to the moon as kind of a waypoint for further in-depth exploration of our own solar system. And one of the things the European Space Agency is going to do is set up a communications network. And they're going to be putting together a constellation of satellites that looks something like this. You can see that there's going to be, somewhere around a dozen or so satellites that orbit the moon and allow communications to be relayed from the far side of the moon to the side of the moon facing the Earth, and then passed along to us. There is already a similar type of arrangement on Mars. Whenever a Mars orbiter inserts itself into Martian orbit, they are set up with similar frequencies to the ones that are already there, so that the various satellites that are orbiting Mars can communicate with one another and relay signals back to Earth. So the same idea here, and this, however, is being spearheaded by the European Space Agency. And I thought that was very interesting.
This is an interesting.
Tim had the same idea that I had. Wi-Fi on the moon?
Wi-Fi on the moon. Wi-Fi, you can do Facebook and Zoom on the moon.
This is an interesting view of the moon. I'm not sure where it was taken.
It is an interesting
because
view.
This is not from
This was
Earth.
not taken from Earth.
Yeah,
you're right.
Yeah, that's true. This was probably taken by one of the orbiters on its way in.
Yeah, it must be. Yeah. So are these satellites all going to be connected by those little threads?
Yes, yeah, they all
Right.
they all have very long. They have very long spools, and
They're
that's
going to be wired.
That's Cat 6 cable.
Right.
No, just kidding, folks. That is not Cat 6.
Right.
All right. So that was my last moon story for the night.
All right. All right. Well, folks, again, we are unable to observe with our telescope tonight because the Chabot Space and Science Center is completely fogged in right now. So if you've got any questions, anything you want to ask us about astronomy, we'll be happy to entertain those questions. We'll try to answer them. If we don't know the answer, of course, as always, we'll just make something up. So, chime in if you
That's right. It
have
will
some
sound
questions.
very convincing.
Yes. Yeah.
But it will be made
What's
up.
really fun is when all three of us are making. What's really fun is when all three of us are making something up and then we argue about it.
Yeah. So someone asked if there's a telescope in Greenland. Not sure.
I'm not sure why that question is that. Was that because of the
The solar
position of the
eclipse.
moon?
No,
Oh,
he's
to observe the eclipse. Yeah,
Oh,
that would be a good
okay, yeah.
question. I really doubt it. I really doubt it.
You don't think there are
Yeah.
any telescopes in
There is another
Greenland? Huh?
question I want to respond.
Greenland is a very
Well,
misnamed
not
continent.
broadcasting on Zoom. Yeah. I would like to mention that these sessions are recorded. Somebody did ask that. They are available both on YouTube and on Facebook. So you can go back and see all of the programs, virtual programs that Chabot puts on both of those media. And feel free to watch the reruns.
Yeah.
Watch us argue about what are those stars next to the moon.
Right.
All right. Well, we're looking to see if there are any more questions. I don't see anything on YouTube. John, are you looking at Facebook?
I'm looking at both,
Okay.
and I'm not seeing any new ones.
Yeah, so now's the time to ask your questions about what we saw tonight or anything else that's on your mind about astronomy or telescopes.
Or anything else if you just want to talk about it.
I figured I will take a minute here to talk about, we did look at a lot of images of the eclipse tonight, and I thought I would take a minute to encourage people to learn how to photograph the moon. And if you have any interest in astrophotography whatsoever, I maintain that the best thing to start with is the moon, because first of all, it's big, and it's
bright,
easy to find,
easy to photograph.
it's bright. You don't have to track it. You don't even need a telescope, right? You could even just do it, with a camera and a lens. I'm not a giant. Honestly, a lot of people ask me about using a cell phone, and I've even done programs for Chabot on cell phone astrophotography, and it is an interesting challenge, but it's not my favorite. I really think that using a camera with a larger lens will capture more detail and give you more flexibility, and it's easier to use. I think a regular camera, I think, is easier to use than a cell phone for nighttime photography.
Yeah,
So
that moon image. I'm sorry, that moon image that Jared submitted a while ago, that was taken not through a telescope. It was taken with a 200 and I think he said 230 millimeter telephoto lens on his DSLR camera. So
right. Yeah, I think you can get really great results with the DSLR camera and a lens, and your exposure times are going to be reasonable. The ones that I shot through the telescope, the ISO is at ISO 100, and I was shooting at anywhere from 100th to 200th of a second. During totality, I increased the exposure a little bit, right? I went a little bit slower. And of course, there wasn't an f-stop because I didn't have a lens on the camera. I was just attaching it directly to the telescope. But even if you're using a lens and not a telescope, it's easy to do. All you need is the camera, the lens, tripod, and try different exposure times. Become comfortable with the camera at night. And the other thing that's very helpful is some means of remote controlling the shutter. That's another thing to learn about nighttime photography. And you can get little infrared controllers for most cameras, Nikon and Canon cameras, that will allow you to trigger the shutter without touching the camera. Or there are intervalometers, they're called intervalometers, that you could cable to the camera through a port that's on the camera that just has a wire, and you hold the intervalometer in your hand, and you could adjust your basic settings from the controller in your hand and actually remotely trigger the camera without touching
and
it.
That's so important.
More important. Yeah,
it's so important because touching the camera
right.
moves it so much and starts it rocking too.
Right. So anyway, I encourage people to really start experimenting with that. And once you master once you master shooting the moon, once you master photographing the moon, you're really well poised to try other astrophotography targets. But that's the one to start with, in my opinion.
And then you graduate to
There you
the
go.
Orion
End of
Nebula.
sermon.
All right.
Yeah, sure. Why not?
Yeah. All right.
All right.
What
Bob
are
says
the
he
Star
has an
Trek
image
lights
that he
behind
posted
John?
to
Those are
the
not Star Trek.
EAS.
Yeah, what you see behind John is not Star Trek. That's a scene from the movie Forbidden Planet.
Yes, it's already been answered a couple of times on the comments.
Yeah.
Yes, that's my Krell lab.
I am looking for Bob's image that he said he posted, and I actually can't find it. So I'm sorry, Bob. I actually can't find it that way. So maybe next time you'll have to send it off to me somehow.
Well, if there aren't any more questions, I want to remind everybody once again, Chabot Space and Science Center is closed right now due to the pandemic. We will be reopening in the fall. We are still doing lots of work up here, working on our virtual programming, refreshing the exhibits, actually building a new exhibit area. There's quite a bit of work going on inside the facility. And since we don't have visitors right now, we don't have the income that we would normally get from visitors. So we are relying a lot on donations. So we want to encourage you. If you're on Facebook, there's a donate button somewhere around the comment section, and just click on that and help us out. You can also go to the Chabot Space and Science Center website. The website is chabotspace.org, and you'll see a donate button at the top of the web page, and click on that and make a donation. We would really appreciate it. We can always use all the support we can get, so we can open up in the fall with a bang.
All right.
Okay, well,
Thank you all for
finish.
joining us tonight. Yeah.
I'll finish up by passing
got
along.
something?
I'm just going to pass along a space joke from Little V, who is, I forget her age, 5 or 7, something like that. And the joke is, what are the planet's favorite days of the week? And they're Saturn Day and Sunday. So with that, good night.
All right.
Not to mention Moon Day.
Yeah, right.
Moon Day. Yeah, you forgot Moon Day, Little B. All right. Take care, everyone.
All right.
Yep.
All right.
Thanks for putting up with us.
Yeah.
We'll
Good night, everybody.
see you later.
Good night.